Now that we're familiar with basic identities, sum and difference formulas, and double angle formulas, it's time to take a look at the collection of half-angle formulas. Half-angle formulas are used to express information about an angle that's half as large as the angle that you use in the formula. So in this case, we want information about an angle, and we're not sure what it is, but we do know the information about an angle that's twice as big, and we use that instead. So, for instance, let's say we want to know what the cosine of pi 12ths is. Now we know that pi 12ths is half of pi 6ths, pardon the way I've written that there. Then we would use the formula for cosine of theta divided by 2 with pi 6th as our input. So it's important here that the input is not what you want to know, but it's this secondary writing of what you want to know. You express something else that is twice as large, and you have it multiplied by half. So pi 6 times 1/2 still equals pi 12ths, but pi 6 is something we can use in our half-angle formula because pi 6 is something that we know information about. So let's take a quick rundown on these formulas. Sine of half of theta equals the positive or negative square root of 1 minus cosine theta divided by 2. Cosine of theta halves is the positive or negative square root of 1 plus cosine theta divided by 2. Notice that the only difference there is the plus or the minus sign in front of the cosine theta. Tangent of theta halves equals 1 minus cosine theta divided by sine of theta, or sine of theta divided by 1 plus cosine theta. Now, it is going to be up to you to determine whether or not your half-angle value, ultimately, needs to be a positive or a negative. And that positive or negative is going to be determined by the quadrant that your original angle of interest is in. So when we were looking at pi 12ths, just before, cosine of pi 12ths, we're saying what quadrant would the cosine of pi 12ths be in? Which quadrant is pi 12ths in? And the answer, of course, is quadrant 1. We're not so interested which quadrant that pi 6th is in, because we're just sort of exploiting the fact that we know stuff about pi 6th. Pi 6th was never the objective of that problem. So be careful and remember that you're concerned about the original angle of interest, not what you end up using in your formula.